Experience with Nick, Mike 0, November, Tango Victor. Before we start, I'd like to share some information with you. In order to ask a question during this session, please submit that question to our chat, and we will collate those, and at the end of Nick's presentation, then I will present those questions to him. Thank you all so much for attending this session, and Nick, thank you for sharing your information with us for this session. So at this time, I will go ahead and ask Nick to go ahead and share a screen.
Okay.
Okay, and I can see the screen, Nick, so I will turn the session over to you.
Thank you very much, John. Thank you. And yeah, well, afternoon, everybody. And thanks for coming along. And what I'm going to do for a few minutes this afternoon is just share a bit of my own kind of homebrew experience. I'm a relative newcomer to ham radio. I've only really been involved for about 3 years, although I've always been interested in radio and electronics, from building little crystal sets and kits and stuff. But it's something I've kind of picked up and put down, you know, over the years. Now let's make sure this is working. Yeah. So when I first got interested, it was really when I started doing my intermediates course, and I started kind of playing around building analog VFOs and trying to get them to stay on frequency, and messing around with that, and started to get interested in it. Some of what I'm going to be saying, because my particular area of interest is scratch building SSB transceivers, will probably be some crossover from the illustrious Mr. Giuliano. And I should say from the outset, I've had a number of correspondence with Pete over the years, and he's been absolutely brilliant. It's so encouraging and helpful, and just kind of encouraging me and spurring me on to kind of go further, really. Matter of fact, it was from Pete and Bill on the Solder Smoke podcast that I even found out about the G-QRP club, because they were talking about Sprat, and then you've seen the latest edition of Sprat, and I thought, what is this Sprat thing they're on about? For those of you that are not subscribers to the Solder Smoke podcast, they're very complimentary about the G-QRP club, and they have this great phrase where they say, you know, if you're not a member of the G-QRP club, you're just wrong. And I love that. But anyway, so very quickly I determined that when I discovered the G-QRP club, wow, there's other people there that are really into kind of building stuff, because you know, I joined a local radio club, the Flight Refueling Amateur Radio Society, in between Poole and Wimborne on the south coast, and I've got some home brewing friends there, but also there's some people there that are not remotely interested in that, and that's all right. You know, we're a broad church in ham radio, but it was great to be to meet some other people who share that kind of passion. So so I'm just going to do a little kind of show you a few, and there's plenty of pictures and stuff of some of the stuff that I've built, and hopefully get a bit of time to show you what I'm working on at the moment, which is very much a work in progress. So the first kind of proper scratch built radio that I made was this. Now I'm just going to have to move these little things out of the way. I can move this out of the way, can't I? Yes. Put it at the top or something. That's lovely, so I can see what I'm doing. Was a 40 meter SSB superhet. Now it's actually a very old design. I had a book on my shelf, the Radio and Electronics Cookbook, published by the RSGB, and I had it many years before I was ever interested in ham radio. And there was a design in there for the Colt 80. I don't know whether anybody remembers that. And it had an analog VFO, and it was just an 80 meter superhet. but it got you to build in a modular fashion, which is something that I've always internalized and always tried to do, which is a great way. So you build a little bit, test it, and then you move on to the next bit, and then you put that bit with that bit and you test it, you know, which is seems a sensible thing to do, because you can kind of iron out all the faults as you go along. So it began life as a direct conversion receiver. But I contacted Pete Giuliano because I'd seen in Sprat a design for a transceiver that I'll say more about in a minute that he'd done. But what particularly interested me was his impedance matching between the different stages. And I hadn't really come across this. And to be honest, I didn't really understand it. So I kind of asked his advice about this, and he was very kind of helpful. So I did that. I also borrowed the idea that I found in his design of pairing together, now, is this not moving? Oh yeah, pairing together the Arduino and the SI5351 phase lock loop signal generator. And so kind of, I call this foundations because I mean, this is the inside of it, obviously. There's things that I kind of did even this early stage of Homebrew that I've taken with me as I've learned more and progressed more, but I've kind of held those things. So one is this pairing of the Arduino and the SI5351, and although I've built many analog VFOs and even dabbled with Hans Summers's, he did some work on Huff and Puff stabilized analog VFOs, which I submitted for the intermediates project actually, but it's very complicated, and actually it was a lot simpler once you get your head around messing around with the Arduino to get this stable VFO and BFO. The Manhattan style of construction is one that I use. I started off using single-sided copper board and then getting the hacksaw out and chopping up little squares. I know you can buy, you know, the me squares and me pads and whatever, but I thought, you know, I'd try and make my own. But it was hard work, to be honest. Until I bought from a famous auction website a job lot of, I thought I was getting a real bargain of copper clad board. When it came, it was so thin, it was just rubbish. I mean, it was like you could cut it with a pair of kitchen scissors. And I thought, well, this is no good. But then I thought, hang on a minute, you can cut it with a pair of kitchen scissors. And this is great. So that's what I used. So I used, and I've bought loads of this stuff. So I use this, and because you can cut them any shape you want, so I make the little pads with this very thin single-sided copper board, and then it gets super glued onto a decent kind of density board, and so that's how it goes. And the third thing is inexpensive enclosures. I mean, Hams have always been building radios in mint tins and everything, haven't we? Really, this is a Scottish shortbread biscuit tin, which unfortunately I had to empty first. You know, the sacrifices that we make for Homebrew. Right, okay. Now, after I completed this radio, I contacted Pete Giuliano and said, look, I built it, thanks for your advice and whatever. I even put one of his IF amps in there that I think, yes, that he put on his website. And he sent me a nice email back and said, well, that's very good, Nick, but actually with a few more stages, you could have a transceiver. And I thought about this, and I thought, well, rather than butchering this radio up now, perhaps I ought to build it properly. So this is Pete Giuliano's sudden transceiver that appeared a couple of years ago in Sprat, in two editions of Sprat. And I built all these modules, but they didn't all make it into the final radio. By this stage, I'd also bought a book by Eamon Skelton and Elaine Richards called Building a Transceiver, which next to my copy of Experimental Methods in RF Design is probably the most thumbed book that I have, homebrew-wise. There's loads of great modules and stuff in there. So there were some things, and there's an RF amplifier, particularly that Skelton has, which is really very good, very linear across the entire RF spectrum, which I used. So, and I played around, you know, I mean, I must have built about 4 different microphone amplifiers from different designs and put in the one I like best, you know. And that's the great thing about building a modular style. You can just, you know, take it in, take it out as you like. Right, okay. So what's in the sudden transceiver? Well, you can see it there. This actually is this is about the most professional enclosure you'll ever see me using. I think it's one of those fuse boxes. They're all over the internet, aren't they? Anyway, you can get them fairly cheaply. But it uses a colourful display. 2 VFOs, kind of. They're not 2 independent VFOs. They're like a memory, really. But you can have 2 places basically in the 40-meter band. It's only for 40 meters. LSB or USB, you might wonder why that's necessary when it's just 40 meters. But Pete, I think, built some extra circuitry after his original design and used it for FT8, which you know, means USB. I've not done that. But I kept it in there because it was part of it. It has an RF preamp. It has to have an RF preamp because there's no IF amplification at all in it. There's only the audio gain stage. It has a 1 kilohertz tuning tone, which I could produce within the software on the Arduino. It's capable of doing it, but I couldn't get it powerful enough to actually be of any use. So I confess I went the easy analog route and built a little analog oscillator, just a tiny little thing that did me a tuning tone. It's got a MOX, a manually operated transmission switching, it's like the equivalent of just keeping the PTT down when you're testing it. 12 volt supply, it draws about an amp on transmit, and it has the PA is 1 single IRF 510 MOSFET, and depending on how conservatively you bias it, you can put out about 5 to 7 watts, and it's a great little rig. It is a great little rig, and I've used it and had some good contacts on it on 40 meters. It's good fun. Now, I think I've just got a few photos here. Yeah, so I can whiz through these really, but you can just see some of the things. That's this. Hopefully you can see my mouse flicking around here, but there's the SI5351, and I used an Arduino Nano in this sort of small kind of form factor. I also managed to get to find space to have the loudspeaker. I don't really do headphones and things, but the loudspeaker actually horizontally out, which is great, you know, because when you sit operating a radio, you don't really want the speaker shooting vertically up in the air like most of them do. And you note the Club Sales crystal filter down here. Right, okay, so and I managed to stack some of the modules along here as well, so we could kind of get them in a bit more easily. I even had some space. My goodness me, how did I manage that? Okay, so once I'd finished that, you start thinking, you know, about, okay, I've learned some stuff building that. What would I do next time? You start thinking about the next. Now that the sudden transceiver uses 2 NE612. We talked about this yesterday, SA602, 612. They're all the same, active mixer chips. I wanted to have a go at trying some different mixers. I had a play with some ADE1, some passive commercially available mixers. And I thought, well, I'll have a go at kind of homebrewing my own mixers, diode ring mixers, which I did. And they worked really, really well. They had the advantage as well that you could put a little 100 ohm pot on it and kind of null out the carrier far more effectively. It's very hard to control that with an NE612. So that was good fun. Unfortunately, this is where the breadbin thing is. I'm building up to here. When you build your own mixer, it takes up more space, and not only did it take up more space, but of course, you know, when you use a passive double balance mixer, it really needs 7 dBm, which I think is about 5 milliwatts, to drive it properly. Well, I couldn't get that from my SI5351. I couldn't get that level, which meant I then had to build two RF amplifiers to amplify the local oscillator. So one for each clock, the two clocks that I use on the transceiver to make it. So you see, when a large project is now getting larger and larger. But also, I also wanted to play around with a proper IF amplification stage, which thus far I hadn't really properly done. And I thought, well, it'd be nice to have an AGC. It'd be nice to have an S meter. I could play around some active analog audio filtering just to roll off some of the high frequencies and things. It'd be nice if we could have a little bit more power. And possibly to play around with some different architecture for the radio. So this is basically the central section of the sudden transceiver, the little blue 40 meters one that I built. This is the Pete Giuliano one. So green basically is receive, and red is transmit. And you'll see, and Pete referenced this yesterday, there's basically one-way traffic through this radio. The signals, all the signals move from the left to the right. Doesn't matter whether you're on transmit or receive. Now, the only way you can get away with this, and the only way I could get away with this building this radio, was that you have to swap the clocks on the SI5351 because clearly, when you're on transmit, the left-hand mixer needs to give you, I mean, I've got a 9 megahertz IF here, needs a 9 megahertz LO signal. But when you're on receive, it needs a 16 megahertz signal. So the only way you do it, and I think Pete admits that he tried to do this within software and he could manage it if he can't manage it. So I went with him and used a relay, a little double pole, double throw relay, and crisscrossed it. So when you key the PTT, you actually swap the clock feeds over so that the right mixer gets the right signal, and it works really well. But I thought I'd be interested in playing something a bit different. So I think this was the next one. Now this is this is where the breadbin comes in. The Breadbin 80. Now I found these breadbins. I was looking for an enclosure. As I was building this radio, it was getting bigger and bigger. I thought, there's no way I can put it in the same size enclosure that I put the last one in. Even if I strapped two of them together, it still wouldn't get it in. So I thought, well, what about a breadbin? Because we've got quite a big breadbin at home here. I thought, well, if there's something that I could just get some more stuff in. So I found these. They weren't very expensive. I think I got it on Amazon. And it works really well because it's metal. So it's got a fair bit of shielding, but it's not too difficult. You can get through it with the nibblers to cut out, you know, the spaces for the LCD screen, and you drill it pretty easily for everything else. So that's why. Now, the modules in here are based largely on Eamon Skelton designs. And it is largely an analog brute. It did actually feature on episode 222 of the Solder Smoke podcast, because Bill Mira and Pete were quite taken with it, particularly Bill. I think he's interested in analog lockdown rigs that they were doing at the time, and this was mine. And I, other than the fact that yes, it has the usual SI5351 and an Arduino Uno, I think, on this occasion. There, and it's got it's only a little basic 16:2 LCD screen this time, and a rotary encoder. Everything else is analog, and I was really playing with it, and I call this my learning rig. It's not a design you would ever intentionally build. I would have to say that. In fact, I did wonder at one stage whether it would ever be built, because it was me playing with different modules and, you know, thinking, oh, can I do my own mixer and what up, you know, an IF stage. But having built all this stuff, I thought, really, I've got to put it together and do something with it. Hence the breadbin. It has a 3-stage IF amp, it doesn't need an RF preamp. It's got an AGC, an analog S meter, as you can see. It has an active analog audio filter, which is, I mean, I don't use it that much, but it's okay if the band is, and it's obviously only 80 meters, but if the band's really noisy, it'll just take off some of the higher frequency hiss and stuff, which can make some stations a bit easier to copy. It will technically, out of the box, well, out of the bin in this case, it's not a QRP rig, but it depends how much you feed it. It's a dual power supply. So the main rig takes 12 volts basically, and the PA will take, well, whatever you want to give it. If you feed it 19 volts, you'll get about 25 to 30 watts out of it. When I activated the club call sign, the G5LOW, a few weeks ago, I just turned the power down to 12 volts onto the PA and got 10 watts out of it. So it's, you know, it's whatever you want it to be, really. So it's quite adaptable. As I said, it's got homebrew mixers, even a homebrew crystal ladder filter, mainly because I bought a whole load of 10.7 megahertz crystal filters from Telford last year. I thought, oh great, until I got them home and realized there was wide as a barn door, and so and by this stage I'd already built some stages for 10.7 meg, which is not an ideal IF anyway, really, but it was, you know. So I think that my crystal filter was a kit from Spectrum Communications down the road from me in Dorchester, but everything else is kind of scratch brewed. So this is inside it. As you can see, there's not a lot of room to maneuver. So I'll just kind of keep an eye on the time and whip through this. So yes, the little penguin tin here, this is the crystal filter inside there. And this is the power distribution board for the, some modules have power all the time. Some have power on transmit and receive, you know, some have different voltages, whatever, like the Arduino and the SI5351. So that's all kind of controlled here. Right, let's go. So this is the PA. Now you'll see here, there's two, these are IRF 510s again, back to back here. I can't tell you how many MOSFETs I destroyed in the making of this rig. It was just horrific. I remember emailing Graham and saying, Graham, I'm gonna need like another 10, mate, because I'm just, they're just so easy to kill. Very, very easy to kill. This PA is a design that's on the at least 3 different versions on the internet. When this was all strung out on the bench, this actually put out 50 watts. But as soon, I think Pete mentioned this as well, or somebody did yesterday, as soon as you shoehorn it all into an enclosure, there's no way I could get anywhere near that, just because of all the spurious oscillations and everything else going on. So I settled for 25 to 30 watts, and that was fine. As I said, you can easily turn it down. The driver, this is like one of these old CB NPN power transistors here, which are on a heatsink. Puts out a watt, which was too much really for the PA. So I built a little 3 dB pi attenuator there just to take that down. Right, okay, so where are we? Oh, that's just another one there. You can see some of the modules. I mean, I had to stack them 5 high to get them in. So, I mean, it does raise a serious question actually about shielding, because there's virtually no shielding. I have no room for any shielding, you know. So if you were designing this, you would not build it like this, but it does work, and it works very well. I get some very good signal reports from this radio. Now this is the architecture of the Breadbin 80. Now you remember the last one, it was all one-way traffic from the left to the right. This is 2-way. I've not actually built Asher Farhan's BitX or micro BitX, but I've seen his schematics, and it's a similar kind of thing. So you've got 2-way traffic going through the central IF section. Now, if you look at this, I know what some of you are probably screaming at the screen. I mean, I could save myself, look how many relays there are just in this section. I could save myself a whole bunch of relays and amplifiers if these were bi-directional amps, right? That would make life a lot more. Well, it would, yeah, if I'd have thought about it and planned it, but it didn't happen. The rig didn't happen like that. It grew and morphed into what it was. As I said, if you were sitting down to plan this properly from the beginning, like maybe I should have done, you would have bidirectional amps and you wouldn't need necessarily all these relays, and you could optimize this far more. There are some advantages to this architecture though, I found. One is you don't need to switch the clocks, because this relay, the thing is, this mixer here sees no audio at all. All it gets is it either gets an RF signal in on receive, or it gets an RF signal out on transmit. So I built a little diplexer here on this port here, from the IF port, and similarly on this mixer here on the right, this port here only sees AF. So it's not like on the sudden when you might have a microphone input in 1 minute, and then you might have an RF signal from your antenna coming in on receive next minute. So what it means you can keep all the RF on this left-hand side and all the AF on the right-hand side, which I thought, I kind of like that, you know. So it meant I could build an audio filter on this port. So I didn't need any RF going anywhere near this at all, which was great. So I could kind of keep that separate, and that seems to work pretty well. So what's next? Okay, how are we doing for time? Well, not too bad, not too bad. Well, what's next is I have, I confess, crossed over to the dark side and started delving into software-defined radio. It couldn't be more chalk and cheese, really, from the Breadbin 80. So this, at the moment, is an 80-40-20 tri-band SDR phasing rig. And it's based on the superb work of Charlie Morris, ZL2 CTM, who was mentioned yesterday, and uses a Teensy 3.2 microcontroller. Now, there was some mention of this yesterday. If you've not come across the Teensys, they are like an Arduino on steroids. I think if an Arduino Nano runs about, was it 25 megahertz or something, the clock speed, the Teensy 3.2 runs natively at 72 megahertz, but I overclock it safely to 96. I've got, well, here, I'm not sure you can see, I'm probably a little window, but on here, on this little breadboard, this is a Teensy 4.0. They actually got to 4.1 now. This runs at 600 megahertz. I think there's more power in this thing than the first 4 computers I think I ever bought. Yeah, incredible power, incredible power. So when you're doing analog to digital and digital to analog conversion, it's brilliant, because the Arduino would have given up and gone home long ago. So it's a superb little thing, really. I'm not going to go into too much detail about this, because I want to leave some time for questions. And it's a whole talk on its own, because it's the whole phasing structure of it. But just very briefly, you essentially clock your SI 5351, which is down here, at 4 times the amount. There's different ways of doing it, and Charlie's got at least 2 different ways of doing it. But this is one way of doing it, is to clock it at 4 times your chosen frequency. You then put it through, well, this is a 7.4 AC7.4 dual D-type flip-flop, which effectively just divides by 2 twice. And that actually gives you the quadrature I and Q signals for the local oscillator, which then gets fed into the mixer. You can't see the mixers on the bottom board underneath here. And then the other bit of phasing happens within software, within the Teensy itself. And as Pete mentioned, you need to delve into the Iowa Hills software on the Iowa Hills website, which is superb. I think it's an American guy who was an RF engineer, I think, before he retired, and has produced this Windows software, which is superb for producing Hilbert Transform filters. And a Hilbert Transform, if you're not aware, a Hilbert Transform is like a kind of software equivalent of a crystal filter, but with very, very sharp, steep skirts, and with phasing as well, which is really useful. So this is, and I think someone mentioned as well yesterday, I did put a comment on the chat about, I think it's Pete, about the idea of marrying up the spectral display and the waterfall with the SDR, which strangely enough, even Charlie Morris has not done. I actually took his code from his pan adapter, which he never actually connected to his SDR. His SDR had just a frequency display. His pan adapter was on a tap, an IF tap on a kind of super hex designed transceiver. But I wanted to do the two, so I've taken his code and adapted it. And it's great. You only, because of the Nyquist frequency, the Teensy has an audio board which samples at CD quality, so it's 44 kilohertz. So because of the Nyquist frequency, you can only sample half of that without getting aliasing. So you've got basically 20 kilohertz. So, you know, AirSpy and SDR player not exactly going to be quaking in their boots with this, but it's useful, and you can see it. And also the frequency of interest is offset on the left at the minute. There are ways you can move it and the rest of it, but I won't go into that now. But it is useful, and you can see if there's strong signals when you're tuning along. You can see if there's QR, M or N, you know, you see, and obviously you can adjust the colours in the waterfall and everything as well, which works really well. Probably the best thing is these Hilbert Transforms. Charlie Morris just put one in his initial rig he did. I have 8, which is quite an undertaking because you have to design them in the Iowa Hill software. And depending on how many taps you have on, as they call it, well, I have 100. And because in the software, instead of putting one, you have two streams of audio, instead of advancing 190 degrees to get the required shift, I do the trick that a lot of people do, is I put phase shift on both the streams. So I put one on 45 degrees and one back 45 degrees, which gives you the overall 90. But that means then you've got to design one filter that has a plus 45 degree phase shift, and then you need one that's and so there are 100 each, and I've got 8 of them. Then you need to and that software spits out your coefficients. You need to pass that then into a C++ array that you can put into the your Arduino code then to make it work. But it is brilliant, and it's this kind of thing that my flashy Yaesu rig has. You know, when you turn the bandwidth down, and you hear it closing down as you narrow the bandwidth, or you hear it opening up. You know, and that's all it's doing really. But really good to be able to do that on a homebrew rig, and to be able to kind of see that as well with the visual thing. As a receiver, it works superb. Really, really pleased with it. On transmit, I have to confess, I've ripped the transmit board up at the minute because I'm playing with some separate transmit mixers, and I'm thinking that this uses any 612s. Jury's out really whether you ought to just go to passive mixers for this kind of thing. I am actually playing with the MC1496, which has got a lot more biasing resistors on it, but you can null out the carrier much more easily. The problem I was getting with the NE 612s is that they make half decent product detectors and RF mixers, but not great balanced modulators. Getting rid of that carrier can be quite tricky, I've found. So I'm playing with that at the minute. So that is, I think, pretty much it. If you want any more details at all, then please have a look at my QRZ page, M0NTV, and my email address is on there as well if you want to send me an email. And there's lots of details and lots more, and there's a few little video clips, plus a talk that I did for a virtual club talk I did for my radio clubs, about 20 minutes, on the actual Breadbin 80 when I documented it as I built it, so you can see it all spread out and see some tests and things going on. But thank you all very much for coming along this afternoon and for listening. And if anybody's got any questions, then I will hand back over to John, who I'm sure will let me know. Let me just stop sharing my screen, and that'll be great. I might just need to move this out of the way first.
Well, Nick, thank you very much. That was an excellent discussion, and I can't tell you how I related to your pictures of boards laying around and wiring going in your early stages. I think we've all had projects that have started off like that, so different than what the final product looks like. We do have some questions from Tristan, G0KAY. Did the voltage regulator bit of the Scottish Biscuit tin radio cause any noise? It looks like a DC to DC buck boost module.
Yeah, probably yes. That's the answer. To be honest, I was with that first rig, I was operating really beyond my level of expertise, which I guess a lot of us do most of the time, don't you? You know, we push the boundaries, and we kind of, and usually what happens is I'll try something and it won't work, so then I have to stop and go back and do some learning and think, well, why doesn't it work? And actually that's where I learn most, you know, when I stuff up, and I stuff up a lot. You know, I should have said right at the beginning, I am by no means an expert at this stuff. You know, I'm just a keen. I put the amateur in amateur radio, basically. You know, I mean, I just like fiddling around and trying it out. But I hadn't. The simple answer to that question is I hadn't tested that. Yeah, the receiver does. I mean, it works pretty well. But there's all kinds of issues now, and if I was building that again, there's noise on the rotary encoder, and now I would just put an isolating transformer in there, which I'm certain would kill that, but at the time I didn't really know about that, so I didn't.
From George DL1CLX, we have, do you write the Arduino sketches yourself?
The simple answer to that is no. I wonder how many people genuinely start from scratch and write Arduino sketches. Maybe some people do, maybe if you're from a kind of a programming background. I've done a fair bit of programming on and off over the years, including a bit of vintage C many years ago, but only in a hobby sense. So I can understand enough of it to adapt it, and I can write little bits myself. But the whole bit of interfacing it with the SI 53, 51, whatever, no, I've just I've copied that. And I mean, the great thing about doing the software stuff is what I've tried to do, particularly with this recent SDR rig, is I've done version numbers. So every time I make a change, I give it a different version number, and I record at the top in the comments what I changed. So if you really stuff up, as I have, you know, you can roll back to a one that works and then undo it. The only thing I have found with SDR is there's a whole new world of pain, because now I don't just have to worry about soldering the transistors around the wrong way, which is my usual pet thing. I was desoldering and resoldering forever, and I realized it was actually a software fault. it was a bit of dodgy code, so you've got to be really careful. So actually isolating where the problem is when you're dealing with all this more complex software stuff is the first thing you've got to find out is the problem in the software or is it in the hardware? And sometimes that can be harder than you think to determine.
From Dave, Mike 1 Delta Golf Sierra, he was wondering about what were some of the ways that you destroyed so many 510s, and he does appreciate that you have at least taken the path of showing us where we need to avoid. So if you could expand on that a little.
Yeah, well, I mean, people say, you know, they can go off like a rifle when they blow. I didn't blow up any of them. I never saw any magic smoke, but I killed them. Now, whether that was, I'm not entirely certain. Is the simple question, simple answer to that. I have a feeling I didn't have the problems until I shoehorned it. Well, wouldn't you know? I mean, it's easy to replace them when it's all spread out on the bench, isn't it? But that's not when you get the problems, isn't it? It's when you put it in the enclosure, then you have to start ripping it all out again. Biasing is a huge part of it, and even though, you know, I'm pretty careful with the biasing. So I know some MOSFETs and transistors are more temperamental about impedance mismatches, and I'm sure I've killed at least a few of them through that, because I don't think I ever killed anything with a dummy load on. It's only when I started messing around with real antennas and that some problems happened. So it's, I mean, the only good thing about it is, I would say, is that they are cheap. You know, you wouldn't want to go doing that with a really expensive RF transistor. Although I'm told, I haven't actually used any of those yet, but I'm told they are a little bit more hard wearing than perhaps. And I mean, we need to remember as well, I mean, the IRF 510 was never intended for the purpose that we put it for. You know, it's intended for switch mode power supplies and things. So, but if you're careful with them, and the truth is, if I'd stuck to my QRP roots, I probably wouldn't have blown up so many. I think it's when you try and work them harder, probably, than they ought to be worked, that you start to get more problems. I never had any of those problems when I was doing 5 to 7 watts in the sun, you know, so it's only because I was aiming for more that I came across it, I think. So, yeah, so no, so I'd be as interested in anybody else, really, if their experience of blowing up MOSFETs.
Rob M0NIL has a question. What test gear have you bought and that you use for these types of projects?
A very good question. Yeah, well, my test gear it consists of, I've got digital storage oscilloscope, not a really expensive one, it's a Chinese one, a Hantex 200 megahertz one, but that works really well. On my first transceiver I was building, well, I've remembered this club actually, another Nick, I forget his call sign now, who built this rig. He says, well, the only way to, and I was having a problem on transmit, I wouldn't get much signal out transmit. He said, the only way to do it is just to go through on the scope, just trace that signal through and see where it starts to go a bit wrong, you know. So an oscilloscope's really, really useful. You need some kind of spectral display. Now, my oscilloscope has the FFT thing, so you can kind of get some idea on that. What I tend to use, I've got here, sorry, but is a little. This is a I mentioned SDR Play. This is an SDR RSP2 software-defined receiver that most people will be familiar with. And there's a guy, Australian guy, I can't remember his first name, who wrote some spectrum analyzer software that runs under Windows for this device, which works really well actually. So you can kind of you might need some attenuation or whatever, but you can kind of get a pretty good display on your computer screen of what's going on. So you can look at things like carrier suppression and sideband suppression and the rest of it. Also for things like filters. I mean, you build these kind of radios, you end up building a lot of filters, bandpass filters, low pass filters. And I always used to use this all the time for that. I have, to use the real flavour of the month this weekend, kind of reverted to a nano VNA, just because that's easy now to check filters and gives a very accurate kind of response. So generally I do that. And the other thing I have, which is really useful, particularly going back to right to the beginning, really, about impedance matching, is a little, where is it? Little peak Lcr meter, I don't know, about 100 quid or something, maybe just under 100 quid. You can get lots of cheaper ones. I don't know how good these are. It'll operate at 3 different frequencies, and for measuring the inductance and the reactance in your coils that you're building, really, really good, because otherwise you're just kind of guessing. I mean, there's some good, you know, toroids.info and things on the internet. You can get an idea, but I feel a bit more comfortable if I can actually see a reading. So, I mean, the truth is, you can do all of this with very little, but it takes longer, because if you don't have access to some equipment, because you just don't know. That's the thing. And I suppose this is where radio clubs, I think, could come into their own, really, because if your radio club has a spectrum analyzer or has an oscilloscope and you don't, I mean, that's I think where we can kind of help each other out with that. And I didn't get it all overnight, you know, I mean, I built it up gradually. But yeah, but good question.
Our next question comes from Mike, AE0IH. Could you recommend some good resources to learn about home brewing? For example, EMRFD, the book from Wes Hayward, Spratt, etc.
Yeah, yes. Yes, I mean, I have to say, it's almost blasphemous to say this really, but I'm not sure RFD is the easiest book to dive into as a complete beginner. I think it helps if you know a little bit first before you do it. But let me just find the book I really liked, which is this Building a Transceiver by Eamon Skelton, EI9GQ, and Elaine Richards, G4LFM. And I may even have bought this at the National Hamfest or something, on the RSGB bookstall or something. But this is superb. There is, and they go through here every aspect of a radio. Even, I mean, it's a little bit dated now, possibly in the when he talks about they uses the AD9951 DDS. Well, a lot of people don't tend to use that stuff now, but a lot of people tend to kind of go the SI5351. But it's really very good, and there's some great stuff. And it's not necessarily a book you have to read cover to cover, but there's some brilliant ideas for modules and things to try. So that would be definitely one I would recommend. The Spratt is superb, and if you haven't got the Spratt, because I'm a Johnny come lately to this, so I've only got a few, you know, actual paper editions of Spratt since I've been a member. So I've got the CD, you know, with all the back issues of Spratt. Get that, because there's all, and there's a somebody's kindly done there's a reference, isn't there, as well, where you can kind of cross-reference. So that's a really good thing, because there's people that have done different bits and pieces. There's depending on where you're at, there's I mean, it's all on the internet, isn't it? I mean, there's so much stuff on the internet. Obviously, I'm bound to say Pete Giuliano, just because there are not many people. I can't think of many other fields, you know, where you can have someone who you really admire and does some amazing things, and you can just contact them and ask them a question, and they'll come right back at you and give you an answer. You know, I mean, it's so Pete's website is brilliant. Charlie Morris's stuff is superb, but Charlie won't spoon feed you. You won't get any, very few schematics. You might get a little scan of a hand-drawn thing. You have to kind of go along and watch the videos and pick it up. So maybe not for the absolute beginner. And Peter Parker as well, VK3YE, his stuff as well, really superb. Trying to think if there's anybody else, but yeah, have a Google round. But there's a number of things that will enable you to just try a few things, and you build up confidence. You know, you build a few things, and then you think, well, I'll maybe try something a bit bigger and try something else.
Well, Nick, we have just a couple of minutes left. Do you have any closing comments before we close the session? Not really. Only just to encourage people to give it a go. I know, you know, someone had told me 3 years ago, well, if they told me I'd be presenting at the G-QRP convention, but even if they said you'd build an SSB transceiver, I would have laughed. I thought that's fine, because when you look at the whole schematic of an SSB, yes, it is a complicated thing. No, it's not an easy, but if it was an easy thing, where's the fun in that, you know? But the fact is, you don't build it like that, you know? You build an audio amplifier. You build a mixer, you know, you build an RF amplifier, and you play around with it, and you get confident with those, building these small things, and then you put them together, and hey presto, you've got something amazing. So please don't be put off if you've never, I don't know what I'm preaching to I'm probably preaching to the converted for many people here. I'm sure you know more about it than I do. But if people are not, they're just dipping their toe in the water, wondering what all this homebrew stuff is about. Give it a go, right? Give it, and there's loads of people that will be ready to help and give you some help and encouragement. And as I said, my email's on my QRZ page, so if you want to shoot me an email, please do. But thank you very much, Nick, for listening. Thank you very much, Nick. And I'd like to thank Andrew, my co-host, G6ALB. excellent session, and I look forward to seeing what your next project is, Nick. So we're going to go ahead and close the session. Andrew, if you would stop the recording. And thank you all.